Hi everyone, I've recently coded a finite state machine component using gameplay tags for use in one of my projects, and since I couldn't find any tutorials online about it, I decided to do a little workshop where I show you how to build it from scratch. We'll be using C++ to create the component and expose everything we're going to use to blueprints. So first off, what are gameplay tags? Well, think of them as a collection of hierarchical labels, each with its own true or false value. They can easily be edited internally from the project settings, as well as externally by using a .ini file. In the context of a finite state machine, gameplay tags are a great candidate for executing small amounts of logic, both in blueprints and C++. So here I am in the third-person example map, and I'm going to use the example map just because it has all the boilerplate already set up for me. I'm going to start off by showing you a traditional example of how you would implement a state machine in a game, right? So the traditional way of doing it, well, the most simple way you can do it is by using an enumerator. So in order to use an enumerator for your states, you have to create an enumerator here. Let's call it player states. And inside it, you have to populate it with labels and values, right? Or just values. You have to populate it with values. So you can populate it with idle, can populate it with moving, you can populate it with in air. And these are different states that the player can be in, right? You save that, you go back to the third-person character, and inside the third-person character, you create a variable state, and here you choose the enumerator player states, right? And for example, on begin play, or actually on tick. Let's do this on tick, right? We're gonna switch on player state, plug the state in, and then just do different things based on what state we are in. This is the traditional way of doing it with an enumerator. Now, using gameplay tags is pretty much the same thing, but the key difference is, there are two key differences actually. Gameplay tags are not a user-defined data type. So you don't actually have to create an asset for them. They are simply a list of labels with a Boolean value attached to them. More so, they are hierarchical in nature, meaning you can have you can have tags within tags and within tags. So you have a parent-child structure to them. Just to show you what I mean, if we go to project settings and we search for gameplay tags, we can see the gameplay section of the project settings. And here we can add new gameplay tags. We can remove all gameplay tags. We can search gameplay tags. We can do pretty much anything you want related to gameplay tags here. And what we want to do is just add a new gameplay tag. Let's call it, and just to exemplify the hierarchical nature of it, we can add idle, we can add moving, and we can add in air. And we can use these values in blueprints just to know in which state we are in. I'm going to show you in a minute how to do that. But first, to exemplify the hierarchical nature of gameplay tags, we can also do something like player states dot idle and player states dot in air and player states dot moving. Right? And now all three of our states are within player states. So what we can use this for is further down the line, when we have more functionality to our game, we can come back and see, okay, what is this state? This is part of the player states. What is this state? This is also part of the player states. And we can execute logic based on this relationship, based on the relationship between the idle gameplay tag and its parent player states gameplay tag. And to remove tags, you can easily just delete them from here. Make sure you don't have them, you're not using them anywhere. And an added advantage to using this over enumerators is also the fact that you don't actually have to create any assets, right? You can just edit the list from here. And you can also create a separate .ini file and modify the gameplay tags there. You can also use data tables for the tags. But I'm going to focus only on using the project settings one for now. So without further ado, let's just begin, right? So we want to create the gameplay, we want to create the state machine component first. the way we're going to do this is by creating a plugin. And the reason why we do this is so that you can actually take the code that we're going to build here and add it to any other project you may wish to use a state machine in. So just go to plugins, click new plugin, select blank, and give it a name. We're going to name it tag state machine, and just hit create plugin. Oh, actually, never mind. Sorry, you can't name it the same name as the project, so I'm just going to name it state machine. There we go. And it's going to generate some boilerplate code for us, the module files and all that. There we go. Now open up your IDE. I'm using Rider, for anyone wondering. They have a special Rider version just made for Unreal, which is pretty cool. And if you go to plugins, you will have state machine here with its source, resources, and so on and so forth. So next, the first step to this is we're going to go to state machine build.cs, and we're going to add a dependency to the engine module called gameplay tags. This is so that we may use the gameplay structures and the types and all those functions that Unreal provides us with, that Epic provides us with. So just add gameplay tags, Control save, there we go. And now it's time to build the actual component. So just go back to Unreal. You can also do this in the IDE, but I prefer doing it in Unreal. So you can hit new C++ class, you can go to actor component, and we're gonna hit it on public and select the module state machine here. This is the module belonging to the plugin we just created. And name it state machine component. And hit create class. And you're gonna wait a little bit, and there we go. It's gonna throw some errors, but it's fine. The class actually gets created. There we go. You can see here state machine component.h and state machine component.cpp. But for some reason, okay, just to fix this real quick, I think we have to do this. No, actually not. Okay. So you can't see my .h file, and that's why it's throwing these errors. So let's just fix this real quick. We're gonna go with state machine / public / state machine component. There we go. That fixed it. All right. Pretty cool. Okay. Now let's just go to the header file for the component, and we're going to declare all our types, all our functions, and all our variables in order. And don't worry, I'm going to go through each of them and actually say what they represent and what they're used for. So here we go. First, we have to declare some dynamic multicast delegates. We're going to use these to know exactly when the state has changed, when the state has been initiated, and when the state ticks. And we're going to expose these delegates to the blueprint system so that we may hook ourselves into it, into these events, and we can create logic from blueprints without touching the C++ part. So we're going to start with, actually, you know what? Let's just leave the delegates for later. Let's just go to the actual variables just so you can get an idea for what the component would look like. So we're going to start with a simple state tag. So we're going to need a blueprint, read, write, edit anywhere. And it's going to be called, it's going to be of type fGameplay tag. And if you're wondering, there are two types you can use. There's fGameplay tag and fGameplay tag container. And just give me a minute because I need to include the actual file for this by going here and actually hitting include gameplay tags.h. There we go. So we have gameplay tag, and as you can see from the autocomplete, we have gameplay tag container. The gameplay tag is a gameplay tag that contains a single tag, and the fGameplay tag container, as you guessed it, probably contains multiple gameplay tags. But for a finite state machine that we're building right now, we just need fGameplay tag. So our state will only have one value at all times. Call this state tag. Right then, we're going to have another property called the initial state that all of these properties you will be able to modify from Blueprint, and it is actually recommended you modify them from Blueprint. Just a minute, let's delete this. F gameplay tag initial state tag. Now we need a Boolean, so we know when we want to actually debug the whole process or not. So Blueprint read write edit anywhere, and we're gonna call it bool b debug equals false. Actually, let's just make that read only and edit. Actually, no, leave it like this. This is fine. There we go. Okay. Next up, we're going to need an array holding all of our previous states, because we want to know the history of our states, right? So I want to know, for example, maybe you want to build a spell that requires the player to have previously been in one of the states of your choosing. The only way you can know the previous states is by saving them in some sort of an array. So this is what we're going to use. You can use anything you want. You can use maps. You can use pretty much anything you want. But I'm going to build them with. I'm going to build mine with arrays. So we have a Blueprint read only, edit defaults only, and it's going to be TRA of type gameplay F gameplay tag. It's going to be called state history. And we also need another property knowing how many states we're going to hold in this state history. I'm gonna edit the defaults only on this one. There we go. And it's gonna be an int 32 state history length. I put mine as 5. You can put whatever you want. Right, now we need to start declaring some functions. So we're going to start with the main function, which is a Blueprint callable function, and it actually is a switch state function. It returns a bool, and it's called switch state, and it requires an input of type F gameplay tag called state tag. So if you can imagine it, since this is a Blueprint callable, and you'll see later when we open Unreal again, and we're going to have all this code compiled and everything, we'll be able to switch the state from the blueprints by providing a tag, which is pretty fun. Right then, we also need some private functions as well, and private variables. And I'm going to explain in a bit why these are private. So we have a Boolean that controls if our state can tick or not. We also have a init state function. We also have tick state function with a float of delta time, and we have an end state. Now, the reason why these three functions are actually made private and not exposed to blueprints is because nobody else in the no other class in our project will be able to externally call these functions. And this is what we actually want, because we want the initialization of any state, the ticking of any state, and the ending of any state to be only called from within this component. So this way, if someone else wants to extend my code further down the line, and I don't know, they want to initialize a state, let's say, since this is private, they won't be able to do that. And it's by design made like this, just so we don't, screw up the whole thing. So init state, tick state, end state, and the bcan tick state variable and functions will only be able to be accessed from within the component. And we're going to see in a bit what we're going to do with them. And now we need some delegates, and we're going to use these multicast delegates in order to hook. We're going to use them as events, and we're going to be able to hook in them from blueprints. So, for example, we'll be able to know when we switch the state, or when we end the state, and when we init the state, and so on and so forth. So we're going to declare a dynamic multicast delegate with one parameter. This one will be f state changed signature. with a constant of fGameplay tag, and this one will be a reference. New state tag. And I'm gonna copy this 2 more times because we need one for the state initialization and the state ticking. So we're gonna call this f init state signature and f tick state signature. And the last one will be 2 parameters. Just like this. And the new state tag will actually be still a reference, but it's just going to be called the init state. We're going to be called state tag. There we go. And the ticking one will be called state tag. But we also need a second parameter, which is going to be a float and delta time. There we go. All done. All right. Now we're going to add some stuff to our U class over here. We're going to call it, I'm not sure if it works with or without, but in my example, in my main project, it didn't work until I added the blueprintable and blueprint modifiers, properties. And yep, there we go. Now we need to declare our delegates. So we're going to go over here and we're going to add our delegates. We're going to declare them as blueprint assignable just so we can access them from blueprint. And this was going to be f init state signature, init state delegate. The next one will be blueprint assignable f end state signature, f init state signature and state delegate. So you're maybe wondering why I'm using the same type here, the same init type, even though there's 2 different delegates doing 2 different things. Well, they have the same signature, so might as well. But normally you can use a different signature if you want. I'd recommend using a different signature. Maybe you want to extend this further down the line, and actually I'm going to change it right now just to be consistent. So f and state signature, the state tag, and I'm going to call this f and state signature. There we go. Now let's copy and paste it since it's much faster like this. We're going to need a tick one and we're going to need a state changed one. So f tick state signature, tick state delegate, and f state changed signature. State changed delegate. There we go, and that is about it for the header file. Now we need to move onto the. We're going to need to move on to the CPP file, so the actual functionality. Writer is really awesome because we can actually auto-generate some implementations, and this is what I'm gonna do here. So I'm gonna auto-generate init state, tick state, and end state. Really cool. There we go. Okay. And now we can start implementing this. So the main thing we want to implement first. Let's go for the delegates, right? So when a state is initialized, you can do anything you want in here. You just need a broadcast for the delegate itself so that blueprint knows when the state is initialized. So we're just going to do this broadcast state tag. We're going to need the same thing here for the tick. So if tick state is bound, then tick state delegate is going to broadcast delta time and state tag, which is exactly what we want. And for the end state, we're going to do some other things, but let's just do the delegate right now. So end state delegate is bound and state delegate broadcast state tag. There we go. Now let's begin with switch state, right? So what we actually need to do here, well, we want to check if the state tag we have just provided matches any tags that we currently have. So we just basically want to check if it's the same state we are in. And if it's not the same state, so if we can switch the state, and we're going to stop, we're going to stop the ticking of the current state. And the reason why we do this is because when you switch states and you could keep continuously ticking, you might end up in a position where the previous state will keep ticking even though there is a new state now, and we wouldn't want that to happen. So we just have a variable controlling if the state can tick or not. So we're just going to disable that for now. We're going to end the current state we are in. We're going to set the new state tag to the provided state tag, and we're going to call init state. After which we're going to begin ticking again. And finally, we're going to broadcast this event with state changed delegate broadcast state tag. And finally, we're going to return true because this is a bool return type. And the reason why it's like this, just so you know if a state change is successful or not from blueprints, right? Now, we have another control flow over here. What if the state is exactly the same? And you can do anything you want here, but the way I have it is if I have debug turned on, then I am logging this as an error. So we're going to say couldn't switch state for %s because it is already in %s. And we're going to bind these to get owner, get name, and state tag to string. So what this basically does, it's going to tell us for which object that implements, for which actor that implements this actor component, the state couldn't be switched for. So the first S will be replaced with the name of the actor that has the actor component, the state machine component, and the second S will be replaced with the toString value of the current state tag. Just so you know, well, not the current state tag, but the state tag you want to switch to, just so you know to which state you couldn't switch. There we go. And finally, we can return false. There we go. Okay. And now let's move on to begin play. So on begin play, we're going to switch state to the initial state tag. This is just to initialize some stuff, just to initialize the state system itself. Then we're going to go to the tick component. And in the tick component, we're going to do some things, a few things. Basically, if we can tick the state, we're going to tick it. So basically, we're going to call take state, and we're going to take tick state, and we're going to pass delta time in it. And if we are debugging, we're going to add a message on the screen. And it's going to be permanent of color red. And it's going to say what the current state is. And the same thing as before, %s and %s. And then we're going to get the owner, get the name, and then get the state tag to string. This is for the current state we are in right now. This is basically going to display the current state. And furthermore, if the state history array is bigger than 0, the length of it is bigger than 0, then we're going to loop through all the state history stuff we have. So all the state history members. And we're going to display a message on screen. Same as before, f color, let's go for blue this time. F string, printf, text with %s. And I'm just gonna bind this to state history of i.toString. So this will show the toString value of that gameplay tag. All right, that's it for tick. And now we're gonna go for end state. This is the last bit we need to do. So in end state, we need to actually add the current state. When we switch states, we need to add the current state to the history. So if you imagine ourselves being in a state, we're going to switch, and we're at some point in the switch, as we previously saw, we're going to call end state. And when we call end state, I want to add the current state before initializing the new one. So the current state we're in, I want to add it to the state history. So if state history is bigger than state history length, so if we still have space in that, just a minute. So if we still have space in that array, we're going to add. If we don't have enough space, we're going to remove the first element. And otherwise, actually not otherwise, but always, we're going to push the new state in, the old state in. So this way, we're going to keep a history of the previous states we've been in. And that's about it, really. So now we just have to build, and I'm gonna close Unreal just so we build cleanly. There we go. And now we're gonna hit Control F5. We're gonna wait for it to build, and I'm gonna showcase this when we go inside. There we go. Successfully built, no errors. And now if you open your any actor, actually, so not just the character, the main character, the player character, or whatever, any actor whatsoever, you can go to the components and you can add a state machine component. Boom. You can name it whatever you want, but we'll keep it like this for now. And if you remember from the first few minutes of this video, we actually, can't find it. There we go. We actually defined some tags over here. We have idle, we have in air, and we have moving. And we're going to use these as examples. So let's forget about our enumerator for now. Actually, no, you know what? Let's keep it here just so you can see the syntax of it, which is pretty much similar. All right, so yeah, we begin. If you remember on begin play for the state component, we actually switch to the initial state. So we're going to leave state tag empty, but we're going to set idle as our initial state. We're gonna hit debug so we see the messages on the screen. And for the state history length, we're gonna set it as 5. So we're going to have 5 states saved for us whenever we switch, right? And if you hit play, oh, I have a hello message. Oh my God, okay. We're doing this, sorry. There we go, and I'm actually going to use this because I can have 120 FPS, actually. Yep, there we go. And as you can see in red, it says the current state for third person character _2 is player states.idle. And you can switch this to whatever you want. So if you go back to the state machine and select in air, you're going to be in air. There we go. Pretty easy and pretty fun. Looks pretty good. Okay, well, where can we take this further from here? Well, basically, we can hook ourselves into the events I talked about and we implemented of the state machine. So basically, you can hook yourself into the init state event. You can hook yourself in the end state event, and you can hook yourself in the state changed, as well as the tick state. So basically, let's say whenever state inits, we're going to switch on gameplay tag. We're gonna add in the state tag here, and pretty much exactly like the enumerator, it's just not built for you automatically. You can select different pins here, and you can select the states you want to switch for. So you have idle here. We're gonna put in air here, and we're gonna put in moving here. And let's say when we init to moving, I want to, actually no, when we init to idle, I want to launch the character forwards. So we're gonna launch it, get actor forward vector. We're gonna launch it by this amount, let's say 5,000. Launch it in this direction, and we're going to override X and Y. There we go. So now, since I have state machine, the initial state tag, I have it as idle, let's say. This should be able to execute, right? Because if you remember, if we go back to the code on the CPP, we have init state, and we're going to broadcast it here. So this is the event that it hooks up into, right? And then it should launch our character forwards. If we play, you can actually see it launches the character forwards. It's just very hard to see because it's pretty much instantaneous. But let's build around that. So let's actually build something you would build in a game. Let's say event space bar. When you press space bar, we want to switch the state. And I'm gonna switch to in air. But we can also have an event called onLanded. When you land, I want to switch the state to idle. And if you remember, when we init the idle, we're going to launch the character. So let's try this. As you can see, if I press space, I'm in air, and when I land, I'm in idle, and the character launches forward. So it's a pretty good way of organizing your logic execution and gameplay execution, right? And you can easily, the best thing about gameplay tags, right, opposed to enumerators, is the fact that you can just simply go to project settings without going into assets, without doing all sorts of stuff. Simply add player states dot dead, right? A dead state. Go back to the switch, add the dead state, and hook it up into launch character. And whenever you are dead, you're going to launch forwards. And let's say if I press spacebar, the player will enter the dead state. So now whenever I press space, I'm going to launch forwards, just like this. So this is pretty cool. A pretty fun way of organizing. Pretty cool way of organizing your gameplay states. And you can do this with any actor, because remember, the state machine is an actor component. So you can actually add multiple states here, for example, for the AI, and you can add a state machine to the AI, which will execute logic based on that gameplay tag, which is pretty fun. And just to exemplify the rest of the events, just to show that they are working. And as you can see, the syntax, as I told you before, the syntax is pretty much the same, right? We're just switching on a gameplay tag. Let's actually delete this event tick. There we go. So we have the tick of the state, and we have, let's see, state changed and end state delegate. So you can, for example, destroy this init state, but have it switched on the switch actually. And you have the tick state, and we can switch on it here. So switch on gameplay tag. And let's say every tick for, let's say for idle, right? So every single tick for idle, we're going to do what? Let's see. Maybe we can do something with the camera. Or actually, no, we're going to increase our size, right? Let's say set actor scale, active scale 3D. There we go. We're going to set the actor scale to get scale. And we're going to increase this by 1 in every single thing, right? I'm going to set it as a new scale. Now I want to reset this. So whenever we switch the state and we go back to, and we go to not dead, but let's say in air. So whenever we go to in air, we're going to reset our actor scale back to 1. There we go. So basically what we're doing here, just to go through the flow of the execution, you can populate end state as well, but I'm just not going to use it right now. But basically what is going to be happening. So when the state switches to init, it will launch to idle. It will launch our character forward. But also while we're being in idle, we should be getting bigger, right? By 1 every tick. Then if we ever enter air, in air, we're going to set the scale back to 1. And we're going to enter air by pressing space. So let's check if this works. Ooh, oh my god, okay. This is way faster than I expected. Let's change it by 001. This is way faster, way too fast. Okay, there we go. You can see ourselves grow bigger, and then if we press space, scale goes back to 1. And if we are back in idle, let me just full screen this for you. There we go. So if we are in idle, we get bigger. If I press space, we go in air and we reset. And then when we land, we go back to idle and we keep getting bigger. So yeah, this is pretty much it, to be honest. This is pretty much it. This is how you build a state machine using gameplay tags. And to be honest, it's quite an elegant solution, right? We only have one component, right? One component with a very few lines of code. And if you need to execute small bits of logic, right? This is probably the best solution you can come up with. This is probably the best solution you can use. Very quick, very easy. But remember, use it for small amounts of code, small amounts of logic. Because if your states are huge, and I mean doing things like modifying the capsule component, setting the materials, setting the colors, resetting some variables. So let's say you have like a huge, amount of blueprint nodes for each state, then this will become unwieldy very fast. It'll still work, but it'll become very hard to follow every single thing you're doing. So if you need something for bigger states, then check out my other tutorial, my other workshop on building a state machine using U objects. Because if your states are huge, then you can use separate U objects for each state to encapsulate functionality. But for simple stuff like we're doing here, this is probably the best. All right, guys, thank you for watching. And I'm going to upload this. I'm going to link this, the project files on GitHub, I think, or on Mediafire. I'm not really sure, but I'm going to link it down below if you need the files. And if you have any other questions, feel free to comment them down below, and I'll do my best to answer them whenever I can. Thank you so much for watching, and I'll see you guys later. Peace.